Hello, everyone, and welcome to the Revolutionizing Agriculture, Navigating AgTech Data and Sustainability event. I'm thrilled to have you all here as we delve into the world of AgTech and its impact on the agriculture and global food security. I'm your host, Tomasz Jamka, and for the next 15 minutes, we'll explore the motivations behind venturing into AgTech and its potential to revolutionize the agriculture industry. First and foremost, please help me welcome our esteemed panelists. I'm going to read that with a background in mechatronic engineering and a Master's of Science in Neurotechnology from Imperial College London, formerly operations manager at Uber, and now the co founder and the CTO of Aerobotics, a South African company revolutionizing the agriculture. Ladies and gentlemen, Benji Meltzer. Hello, Benji. How are you?
Hi, Thomas. Good on you. Thanks for having me.
Thanks. I'm great. Benji, thanks for joining our event. As usually in our events, we all ask our dear audience to type your questions into the chat whenever you feel is the right time. There should be a button like around here. And at the end of our discussion, we'll best to answer as many questions as we can. All right, Benji. Before we start, I think it would be great to discuss what made you venture into agtech, and how do you see it transforming the agtech industry?
So, just sort of a little bit of background. I'm based in Cape Town in South Africa. South Africa's got a big sort of agricultural industry. As you mentioned, I'm an engineer by training. In my undergraduate degree in Cape Town, I met who's now my co-founder of the company, James Patterson. He grew up on a farm in the Western Cape of South Africa. We both have sort of different technical interests. He's specifically interested in aeronautical engineering, building autonomous flying vehicles, etc. My interest is in sort of data science and analytics, software development. And I mean, aerobotics and sort of what we do was really just a combination of these interest areas technically and in the agriculture space that we've got. And before starting the company, I was in the UK. James was at MIT in the States, and we were both entrepreneurial. We were both keen to start a business. This was about 2014. We saw opportunity in the agriculture sector. Farming is extremely difficult to do at scale. There's a whole lot and things that can go wrong at any point in time. This was based on James's sort of background growing up on a farm, and we saw an opportunity to take our sort of areas of interest and combine those to help farmers monitor their crop more efficiently and make sort of data-driven decisions. And it was in the sort of early days of precision agriculture, AgTech, and we combined all these different sort of technical aspects. And that was really the sort of thinking around the business to begin with. Since then, a whole lot of things have happened. A lot of the sort of areas in the tech space have become more commonplace. Sort of drones. We used to build our own drones, as an example. You can now buy one off the shelf. SaaS products in the agriculture space used to be unheard of. Kind of farmers bought tractors and fertilizer. Now buying subscriptions is more commonplace. And I mean, from a sort of climate perspective, it's just become more and more difficult to farm, right? Inputs have become more expensive, and precision's really become mandatory rather than just a nice to have. So this type of technology is becoming more and more necessary. Maybe when we started the business, it was a nice to have, but we just got quite lucky with the timing in terms of being at the forefront of a lot of this innovation.
All right. Yeah, that's super interesting. You mentioned 2014. We are almost 10 years later. What are the major challenges that farmers face nowadays?
Yeah, so I mean, just sort of stepping back, the traditional ways of farming it's done quite preventatively. So what that means is there's so many things that can go wrong at a point in time, and there's so little information on how the crop is actually performing. Typically, farmers will do things like blanket spray their crop with pesticide or fertilizer or water, and you kind of treat every hectare of land the same as every other hectare because it's unaffordable to do away. It's becoming extremely inefficient and unaffordable to farm that way. Resources inputs are becoming more expensive. Fertilizer, I mean, as you'd probably know from your part of the world, is becoming a lot more expensive. The main areas we operate in California, South Africa, Australia, there's droughts. Water is becoming more scarce, difficult to come by. Labor is becoming more expensive. So really, farmers have no choice but to improve efficiency by farming more proactively rather than reactively. And what that means is that they need an ability to understand a more granular level of performance of their crop on a kind of, in our case, a tree by tree level. And they then need the mechanisms to take that information, make decisions, and action them on that level. So from a technology perspective, it means there's kind of a need for monitoring and an ability to capture data from different sources at a higher resolution. There's a need to interpret this data with sort of machine learning models, etc., to turn it into recommendations and decisions. And then from an application perspective, you need machinery that is capable of taking these recommendations and applying them variably through the orchard rather than just in a blanket type approach. And I think it's becoming financially necessary for farmers to do this to operate more efficiently. In some cases, it's becoming a regulatory requirement to use less chemical product, less inputs in the crop. And in other cases, it's just the inputs are so scarce that there's no other option but to use what you've got more efficiently.
Right, right. You also mentioned sustainability. That does AgTech can also contribute to that?
Yeah, I think everything that I've mentioned by nature is around sustainability, right? It's doing more with less. It's food security and the need for producing food isn't going anywhere, right? Populations are only growing, and if anything, we need to produce more tons of crop per hectare of land as we go on. And historically, the way of doing that has been by blasting the land with chemicals and products to up those yields. And while that sort of thing it can be effective short term, sort of year on year, we all know there's long terms. And this type of technology, and not to say that aerobotics is solving all of this problem, but I think the sector as a whole in precision agriculture is really needed to help drive more sustainable farming by nature. It's around doing more with less commercial agriculture.
Right, right. And almost always when it comes to doing more for less, there's an AI. So how it might be harnessed to optimize the agriculture?
Yeah, so in a number of different ways. I think I, I spoke, so using aerobotics as an example, we predominantly monitor crops from different sources of data. That's often remote sensing or remote sources, which could be imagery from drones or satellites. There's different ranges of imagery, so you could get sort of your visual wavelengths of light, you could get multispectral light, etc. They all tell you different sort of aspects of crop performance. There's sensors in the field from an IoT perspective. You've got soil moisture probes measuring how much water there's in the soil. You've often got sensors in the trees themselves. And I mean, as a starting point, it's a huge amount of data. These data sources, whether it's satellites or sensors in the field, are collecting data often multiple times per day at a really high resolution. And it's impossible to consume that data without tools like AI or machine learning. So, I mean, at a sort of core level, there's a need to sort of compress this information into what really matters and what does the farmer actually need to focus on? Farmers are super busy. There's a lot going on, and we often get told this. It's kind of there's only so many things you can show them before they move on to the next thing, and it's as a result, it's really about showing the most important things first. And I guess from an AI perspective, highlighting problems or anomalies and picking those up is one aspect. The next is diagnosing what's causing that problem from a root cause. And once you've done the diagnosis, you could turn that into a recommendation, right? Which could be around what to do as a fix for this problem. And typically, all of this is done through knowledge that farmers have built up generationally through parents, university, etc. It's super localized to that specific farm or that specific area. And I think where AI and this type of tooling plays a role is it almost opens that knowledge up to growers around the world. And I mean, we're seeing examples where like a farmer in South Africa might be facing a super similar problem to a farmer in Chile in South America because the climate's very similar, the crops are similar, and the network effect of AI, etc., allows you to draw recommendations and insights from a broader base and apply that based on the symptoms of the problem that you're seeing. I mean, there's a whole lot of different aspects of AI, if we call it that, from a computer vision perspective to the recommendation engines and etc. But I think it's one of the few industries I've sort of been exposed to where it's almost without AI and these types of tools, it's impossible to build products that add value. So it's really a necessary kind of aspect of the product.
Right. Super interesting. So how is it in robotics? I mean, do you guys? I mean, I'm sure you build your own models. Do you also use LLMs? How does it work for you?
Yeah, so we're not doing much in the LLM space yet. Having said that, with the new GPT, not so new anymore, GPT-4, with the sort of multimodal data input option and being able to load imagery in now as well and kind of combine that with the data sources, we are starting to find that there's value. A lot of what we do is, I mentioned earlier, super localized, and the challenge in agriculture is it's very much a long tail industry. Every tree is different, every farm is different, every cultivar is different, and sort of generalized models that work are really hard. And it's a combination of sort of injecting domain knowledge from an agronomy perspective on how the plants actually work and examples that you've seen in the field. And it's also very niche data that isn't available generally on the open internet. So off-the-shelf LLMs we're finding can help. We're using it more for help in the data curation process to build training sets for our models. So we've got an internal sort of data annotation team that's curating the data sets that we use to test and evaluate what we're building. And we're finding that, I mean, that process can be super time consuming and expensive. You often need to send people out into the field to literally drive out to a farm, take in-field readings. You need to then take agronomists, look at the data, decide what label they're going to give it, and then you train a model off of it. We're using the shelf tools to help accelerate that process, but the actual models that are running in production are very much proprietary, and I don't see open source products sort of competing with that. I mean, having said that, I also didn't expect ChatGPT, etc., to work as well as it did. So who knows
Sure.
what will happen in the future.
Right, right. So that's clear for me. Can you give us some insights? So how did you over the last 9 or 10 years were building your own data sets?
Yeah, so it's been quite. We were a self-funded business initially. We raised venture capital subsequently, but the initial business model, we put everything into building the product ourselves. So I mentioned we were building hardware, drones, sensors, and all of the software. But from then, the business was selling to customers. So we I think 3 months in, we were selling our first products. We were sort of making
Wow.
profit, and effectively the data was getting collected and created by our customers, and we built interfaces for them to label data for us in this. And it's been one of the real differentiators, I think, of the business up until now, is we haven't had to invest. Obviously, we're spending some money ourselves and sending teams out into the field now that we're a bit bigger and building those data sets. But for a sense of scale, we've analyzed, I think it's about 500 million trees now. Our customers have annotated those to tell us if there's problems with those trees or not. We've built the technology for them to walk into the field and do that. So it's really been a sort of crowdsourced exercise, and we vet or validate that internally with our internal agronomy team. But it's meant that we haven't had to out crazy amounts on collecting this data ourselves. And just for context, the main cost in this space is literally travel to these farms, spending time on the ground. It's hard work, and it's work that farmers and customers are doing anyway. And I think from a product strategy perspective, we've kind of been able to position it as you're paying for certain features, but in the process, you're helping us develop future features, which we'll make available.
Wow, that's super interesting. That's a sneak peek from one of our other events. We usually say that the MVP should be 2 or 3 months maximum. So I guess you can confirm that.
Yeah, I mean, look, the MVP that we built back then is very different to what we've got now. But as you just need to get that feedback, and
Obviously.
It's interesting because we often look back now at the deck that we had of our intentions and the product that we thought the market needed, and we kind of say, if only we just built what we had in that deck 10 years ago, we would be so far right now. I think to some extent we almost took too much feedback along the way and got sort of distracted, and we've ended up right back where we wanted to be. But you do need feedback to some extent.
That's great. You mentioned that the biggest cost is actually the traveling, but you also mentioned obviously drones, satellites, how they might be useful. That's maybe not something we use on a daily basis. So please let us know.
Just sorry to understand, how might drones and satellites be useful in this?
Yes, I mean, yeah, because obviously this is kind of an alternative or rather a supplement to just going into the field.
Yeah.
So how do you guys combine all of this?
Sure. So there's sort of satellite options available commercially that you can subscribe to today. They pass over the world at some frequency. They're imaging. In some cases, there's satellites that image the world, every hectare of the world, at least once a day. You can either purchase archive imagery or subscribe to future imagery, or you could task satellites to go to specific areas that you're interested in. The satellites we're interested in are collecting visual, so RGB data. They're also collecting multispectral data, which is infrared information, which just in the context of agriculture, from infrared data, you could measure effectively the chlorophyll content of the plants or the vegetative stress. It's often quite cheap to buy this data. It comes at quite a high frequency, so potentially once a day, potentially once a week. Where it's challenging from a satellite perspective is generally the minimum resolution that you could order spatially is quite big. So you need maybe 1 by 1 kilometer square. And I mean, our product, the way that we sell it is we charge customers. It's a SaaS product. You pay per hectare per year. So we almost need enough coverage of farmers in a certain block to make that affordable. The other challenge with satellite is there's things like cloud cover that happen, which you, again, in your part of the world, I imagine you're very familiar with, and it makes it very difficult to capture that data. So that's where things like drones come in, right? It's an alternative way to collect the same type of information, the same spectrum of data. You just fly the drone at 80, 100 meters above the crop. You're not as affected by environmental pressure. You could collect extremely high resolution spatial data, so 2-3 centimeters a pixel. The difference is it's obviously more expensive to fly. In our case, we've kind of gotten around that with two models. One, We've built a sort of service layer where there's pilots around the world who fly for farmers, and we've got a team that dispatches pilots to go and do the flights. But often the farmers just buy their own hardware too. These drones are
Right.
pretty cheap, and you fly as is. And yeah, I guess to your question, sort of combining this data is where it gets quite difficult technically. It's the same spectrum of light. There's a concept of super resolution, which talks about sort of taking different layers, different resolutions of data, and sort of combining them in a way that you could get the best of all of them. And again, from a user's perspective, I mean, a farmer doesn't need to care if it's drone data or satellite data. They want to know if there's something wrong with their tree. And that's really where the IP comes in on our side, is how to combine these things and use the sort of high temporal frequency you're getting from, say, satellites, with the high spatial resolution you're getting from drones, and there's maybe in-field data, which is really good integrity, and sort of the models in building, combining those is where it gets really, really interesting.
So, just from my perspective as a potential farmer, I get my crop being kind of diagnosed. The data is being uploaded. What's the waiting time? I mean,
Yeah.
how long does it take to process this data, and after what time it makes sense to make any conclusions out of the AI?
So yeah, it's a really good question. There's two separate products that we offer. One is
Okay.
monitoring the trees themselves and the performance of the trees, and that's looking at things like water stress, so how much irrigation stress the trees are coming under, nutrition stress, etc. That's using aerial imagery predominantly. We identify the trees, we analyze them. It's quite a heavy payload of data that needs to get uploaded. It's a lot of imagery. We typically turn that around within a day. So it does take some time to process computationally, and it's fine because these aren't extremely fast-changing problems on the farm. You're able to intervene within a week a lot of the time, and you can still fix a problem. It's not too late. The second product that we've built is a yield estimation product. So what that means is it helps you estimate at a point in time how many fruit you've got in the farm, what the size of the fruit is, etc. There, the turnaround time is a few hours, and it's because the fruits are changing so rapidly in terms of growing at the time that we're measuring them, and the interventions that farmers might take are very sensitive to that sort of growth. So there we're turning it around quicker. I mean, we're looking at things like edge-based processing or sort of local processing. Obviously, the upload of the data itself is also a challenge. You're often in quite rural areas. Connectivity can be challenging. Yeah, I mean, there's a whole lot of difficult or fun, depending on how you want to look at a technical problem in the space.
Please tell us if you can some of these funny stories maybe. I mean, how do you try to overcome this problem?
So I mean, in the early days, in our first office, customers used to literally ship their CDs with the imagery on it. It was quicker for them to ship it to us, to courier to Cape Town from somewhere else than to upload the data. We used to have a museum in the old office of the CDs that customers would send us. Obviously now, with the likes of AWS, Azure, GCP building sort of infrastructure around the world and having like more localized data centers, we've been able to get a lot more smart with how we handle things from a cloud perspective. We do also do quite a lot of edge-based or onboard compute, depending on if it's on a web browser or a mobile device. And there's a lot of compression that we do. There's really good compression algorithms out there. There's a huge amount of IP. I mean, the other thing is just helping avoid the customer from collector that's redundant and not necessary. So the concept of sort of sampling strategies are really important as well, because every tree, I mean, what I was saying earlier, you want to understand how each tree is performing. You could build sort of an analysis of what a representative tree looks like, or representative area, collect data in those areas. So there's all sorts of different approaches. which we're working on. At the same time, connectivity obviously is improving. Things like Starlink have also been super useful for us in really remote
Right.
areas as well.
Right. Makes a lot of sense. Through our discussion, you mentioned a few times like localization being quite unique. You mentioned fruits. You mentioned fields.
Yeah.
I guess it's totally different when it comes to the different species.
Yeah.
What's your coverage? How does it work?
Yeah, so sorry, I should have made the beginning, but we focus very much on permanent crops. So those are trees that produce a yield each year, and it's typically fruit or nuts. So it's things like citrus, apples, almonds, macadamias, etc. The way you could think about these crops is your tree is almost your permanent asset that is producing a yield each year, and your fruit on the tree is literally your current assets in what you're going to sell
Right.
that year. These farmers typically per acre or per hectare, the amount of revenue that they make and the risk that they take on really validates in our view the need for this type of technology. Quite expensive to operate this technology at scale, where in the row crop space, so your annual crops like maize, wheat, soy, etc., it's much lower margin, much lower revenue from a farming perspective, and as a result, the products that you offer them need to be a lot cheaper to sort of fit into that.
Right.
What else is interesting is in that space, there's actually quite a lot of tech entrenchment already. There's like combine harvesters and John Deere systems, etc., which are collecting a lot of data currently, while the permanent crop space is particularly sort of antiquated. It's also very resource heavy. The amount of irrigation you need to do, the amount of nutrition you need to put in. So our approach, I guess, has been to go very narrow horizontally on these specific crops, to go quite deep into the value propositions that we offer them. Again, to build recommendations, we feel like because of how much variability there is between different, we do need to go deep, build big enough data sets, big enough customer bases to understand it.
Right.
And from a commercial perspective, we then try to go vertically up the supply chain. So everything I've spoken to you about now has been on the farmer side and what they could do with this data. But as you can imagine, this information is used in the supply chain as well, whether it's a big part of our business is in the crop insurance space, where this data is used to analyze crop performance. You could do risk modeling, offer insurance products. There's lending, there's farming input suppliers. There's a whole lot of different players. And I guess our view is you can go deep enough, you can really become a platform that enables transaction throughout that chain rather than just this blanket layer
Right.
across all different types of crops.
Makes a lot of sense. Let's dive into so how did you guys manage it from a business perspective? Because then it's theoretically it's easier to get an apple and then the wheat farmer. If you really want to focus, it means really going down to the communities or I don't know, certain geographies. Yeah, how does it?
So, I mean, with our first customer was James's parents. They're still our customer. They happen to be a citrus farmer. So I mean, I made it sound like we focus on citrus because of the value and all of those things, and that kind of is true. But also, his parents farmed citrus, so it worked.
Makes a lot of sense.
And naturally, the second customer was their neighbor, and kind of the way it worked is you build this sort of community network effect. Also, based on the satellite explanation, etc., is telling you there's a density effect where if you can get more people in a network, you could effectively service them for cheaper. And that's really been the approach that we've taken from there. It's sort of this land and specific markets. We've very much followed the crop types that we focus on geographically around the world. So, I mean, looking at citrus as an example, it's been South Africa, California, Florida, Spain, Portugal, Australia, Latin America. All the pockets where that specific crop is really growing.
Right.
The thing with these crops is they're also very seasonal. So they grow and produce a crop for, say, half the year. And that's part of the reason we've looked at sort of northern and southern hemisphere mixes as well, just to make sure that we've got a semi-consistent revenue base through the year. But yeah, it's been super targeted from that perspective, going after very niche kind of areas, partners, etc. As you can imagine, we're always getting contacted by other farmers that we don't focus on, but I guess it's one of the things we've learned is how to say no and just focusing on our core competencies.
Right, right. I hear this often from the founders that this is actually a boost to the business, but you need to be obviously in the position when you can allow yourself to say no. Let's. I wanted to kind of match this with what you said on the AI level. So obviously there are just a selected number of species you work with. How does it look from the model perspective? Do you have these separate models per each like type? Yeah, how does it work?
Yeah, I mean, it's also a really good question, and it depends to some extent. Generally, look with as few models as we can, and transferability is a really like big point of discussion in our business. And what I mean by that is, so I'll give the context with the citrus example. So for us to get good enough performance for our citrus yield estimate, good enough performance in terms of how accurately we can estimate how many fruit there are on a tree, size of the fruit, etc. We needed, I think it was about 10,000 labeled data sets. That then we trained a model off of that data, which was citrus specific. Our approach then for apples was saying, let's go into apples, but rather than starting from scratch and needing 10,000 data points again to get the same level of performance, we would take that existing model, we basically chop the head of it off and retrain a version of that for apples. And in that case, we only needed 1,000. So 1,000 data points. So the general approach is to have sort of four crop agnostic models. And I mean, I'm talking about citrus and apples. There's like thousands of different varieties within each of those as well. And we've used our agronomy team internally to just use heuristics or rules to say, look, these types of citrus are actually very similar. You could expect a soft citrus model in Valencias to work the same as one on navels or whatever it might be. And at the same time, we're looking for patterns in the data to see where similarities exist. But it is quite a manual process, and it's a space where you can't really have one model to rule them all because these things are all fundamentally very different. But there's enough similarity that you could use what you've learned in other contexts to get a head start. And yeah, I mean, like we all over the wall in the office, we've got these sort of hierarchy diagrams of what we call contexts in terms of like crop types, varieties, geographies. Like that's again another one. Like, is a navel tree in the Western Cape in South Africa the same as one in Western Australia? Like, there are all these things that make it really difficult to build generalizable models. But yeah, then there's a whole lot of little tricks that we use to try and do that scalability.
Right. As we move forward within the process, you obviously mentioned that for the farmers, at the end of the day, what matters is a recommendation. So how did you how you produce this?
So, I mean, in short, we don't a lot of the time. It's also a very interesting question from a psychological perspective, or almost a business model perspective. Farmers often don't want to get told what to do, and by that, they know better than anyone what needs to get done. And I think the problem generally is knowing where to focus, and sort of we talk about a lot with our customers. This concept of boots on the ground is always going to be needed in agriculture. So really, the way that we frame the product is to help do that more efficiently and get them to the right places. Give them the tools to do the diagnosis in a semi-automated way and the recommendation in a semi-automated way as well. In some cases, we partner with domain experts or like agronomy companies. So there's often consultants that consult to farmers. They can use our platform to do the recommendation. I think with the recommendation, there's also a liability that comes with it, right? If you're going to say use this type of product or this much, there's consequences. So I guess what I'm getting at is the recommendation is the most valuable thing for the farmer. They need to get that. we help them get and deliver the recommendation ourselves. Our focus really is on finding the right areas, helping diagnose the problem, and from there the recommendation is quite straightforward, but we almost leave that
All right.
to them.
Makes sense. Make a lot of sense. Um, how about the farmers, which are the ones without the technological background? I mean,
Yeah.
how they can benefit from AgTech, like aerobotics?
Yeah, so I mean, it's like with any new technology, you've got that sort of curve of whether
Hmm.
early adopters, the pragmatic majority, or and in
Right.
this industry in particular, there's a lot of people who are pretty skeptical and traditional. Um,
Hmm.
as you can imagine, it's kind of a generational business. Typically, it's and where it's even more difficult is this industry. It's very science oriented. Like the guys make decisions off of research, case studies, etc. That's been done. In this case, the technology is very much leading the science, right? Like a lot of the science in this space hasn't been done, and the technology is just changing so quickly. So often, what we're finding happens is that farmers almost do the science themselves as a result.
Hmm.
What I mean by that is they're very experimental as well. But if someone's skeptical, we'd kind of position this product where, okay, let's do an experiment on your farm where there's a control group, there's a treatment group. Maybe 2 orchards are controlled, 2 orchards are treatment. Let's measure how much better you could do things where our product is. And that's typically the approach that skeptical growers have taken. In some cases, just by us getting like the neighbors on as customers has been enough proof. Um, but it's one of the big challenges in the space. And these experiments also, it often takes a full year to run the experiments. It's quite a slow process. So
Right.
and thinking about sort of growing a business like this can also be really, really tricky. And it's something else we've had to think about quite a lot.
Right. Right. That all makes sense. So, if I understand it correctly, it also means that kind of within the new generations, taking care of the farms, the adoption is growing.
Yeah. Yeah. So you're spot on. And you've generally got like the son of a farmer or something who's come out of university and is quite keen.
Right.
Um, look, it's also often kind of market dependent. So in South Africa, as an example, we were very early with the technology. We were first to market, and it meant that we had this whole challenge of needing to create the market ourselves. So like you had to educate people on what this technology can do, why you should use it, etc. Where somewhere like America and California in particular, around the corner from Silicon Valley, they know it's possible that likely had a demo from someone else in the space as competition. Um, it's almost a very different problem depending on the market and the timing of that market too. Generally, younger sort of new generation farmers do help, but it's more and more becoming sort of common play. It's the same with any new technology in any sort of industry from an adoption
Right.
perspective. I mean, the challenge here is just it's really the like natural seasonality of how long it takes a crop to grow, and in our case, it's annual. Sort of how to speed up that adoption curve is hard.
Yeah. Yeah, makes a lot of sense. How does it combine with the with the AI with the machine learning? I mean, are these are your clients are able to kind of play with it on their own, or they have to do it kind of through you, or just by some default options or presented options throughout the platform?
Can you explain the question a little bit more?
Right. I mean, because from my understanding is that for some people, the platform, the AgTech is designed in a way that I don't need any technological background to
Yes.
benefit from it. But is there like kind of advanced mode where I can kind of play with it on my own
Yeah.
as a client, as a user?
Yeah. So yes, and look, the default mode is sort of no technological background. We run all the models and we
Hmm.
give you the results, and
Right.
you interpret those. There are cases where customers want to almost fine tune or build their own rules off the back of this. Um, the data is all available through API. Some of the super users will kind of pull it into
Right.
their own systems that they've got with additional data, like maybe they've got financial data as an example, and how the crop's performing. They've got market data on what what crops are going to be useful moving forward, that's almost the most common use cases. They'll use this and they'll build their own AI or analytics model to optimize profitability, as an example. Typically, the largest sort of vertical groups are doing this sort of thing. Yeah, there's also, I mean, in the space, you can imagine data privacy is also often a challenge. Keep the data to themselves, almost have their own models. We've thought about building some of this into the product where customers could effectively like label their own data and train their own versions of the model. We've played around with that a little bit. There is opportunity, but the default approach now is kind of you use our models and that's
right. Makes a lot of sense. All right. Let's also move forward and for a moment discuss about the impact, as you mentioned, on the global food security. Are there any innovations around the corner, or some already known developments which may transform the agriculture landscape?
I mean, there's so much in this space. Like, so everything I've spoken up until now has been in the sort of monitoring space, given that's where we play. And obviously, there's just more and more information becoming more and more available, whether it's sensors in the field or satellites. I mean, people are sending satellites up all the time, etc. I think it will get to a point where you've got a near real-time view of the crop at a high resolution. I think the main sort of gap for innovation now is the ability to use that data scalably in acting on the crop. And we're seeing a lot of innovation there in the form of machinery. These are like, I think, self-driving cars, but tractors driving down the orchards, spraying each tree how it deserves to be sprayed. And it's potentially using that data that you've collected from above. It's potentially doing real-time data processing on the machine. That sort of thing is where I see sort of real opportunity happening, and it's in a way that you can apply products variably, right? And it could be water that's getting fed to the trees at different rates. It could be fertilizer, and just mechanization, like in the harvesting space, as an example. For certain crops, picking the fruit off the trees is extremely sort of labor intensive. There's a lot of robotics technology coming there. Some wild things like drones to pick oranges off trees or claws that come off a robot on the ground. And I think all sorts of things like that. Personally, just on the first point, like I see the data just growing and growing and growing, and people's capacity to make decisions is, if anything, getting smaller and smaller and smaller. So there's really this gap for AI to kind of downsample all of this information in a way that people can actually make the right decision at the right time. And yeah, I mean, that's why I see the biggest opportunity, sort of personally. And obviously, there's all the infrastructural challenges we spoke about earlier on connectivity and uploading and all of that stuff. And there's all innovation that's needed to help do that more efficiently.
Right. Is there a chance that all of this will make our food less expensive, or this is rather only be able to leverage the current prices only getting higher?
No, I think it'll definitely make it less expensive. So look, like producing the crop is one of the parts of the supply chain, and this would help you produce a crop cheaper. Generally, I mean, in South Africa, as an example, I think it was like 2 or 3 citrus growers that made a profit last year. Everyone else made a loss. It's a very, very difficult market to make money in, and it's very volatile depending on macro conditions. So, I mean, like we're ultimately trying to stabilize that a bit and help farmers farm more consistently. A lot of opportunities sort of throughout the supply chain as well. Too, there's generally sort of fees on fees on fees and middlemen, and so for orange from South Africa to get to Marks and Spencers in the UK, it's going through like 8 different companies generally, and using better analytics, better insights, better technology, you could cut a lot of that out, potentially. And I mean, that's really where the margin is coming in terms of what you're paying for a fruit in the supermarket or whatever it is.
Right.
So yeah, I mean, we see data. There's a lot of opportunity for optimization in this space. It's and it's the only way it's going to be sort of affordable. It's also, I mean, you would have noticed this. It's kind of a lot more affordable now to buy processed sort of chemical products and foods than produce that are coming from elsewhere, and it's almost indirectly proportional with like your health at the end of the day. So there needs to be something that happens that makes it more affordable.
Is there any recommendation from you, or a message that you can offer to, I don't know, governments, farmers, or even other AgTech companies? I mean, to make a better tomorrow, foster sustainable practices, secure food on a global scale.
It's hard. Like, look, I guess the challenges we've found is there's very little funding. Part of like the venture capital world, we've got there's very little funding to help businesses like us get up and running, and we've had to rely on our customers to pay us to get there. And luckily, the industry has been willing to kind of come along for the ride and learn with us. I think there's a huge opportunity for governments. We see it in other parts of the world where the government are quite involved in helping sort of stimulate this sort of technology. I think it's in the best interest of the market, and I think you see it in a lot of industries where some form of subsidization kind of helps get technology off the ground to a point that it could get cheap enough for the average person to afford it. I mean, something we haven't spoken about, so our focus is very much on large-scale commercial farmers. In Africa, there's a huge portion of smallholder farmers that are subsistence farmers, farming small amounts of acreage. There's no way they could afford this type of technology, and that's where you really need others in the space to come and help subsidize it. And ideally, it's government. If not, there's potentially financial institutions that could offer better financial products to farmers because they've now got less risk because they understand the actual performance of the crop. I think, like, the concern, I guess, that I've got is it's a really industry to build a business in. I've been to a lot of AgTech events around the world. The sentiment's generally quite negative because you don't get the exits as a tech company that you might in, I don't know, fintech or something else. And I think there needs to be some sort of motivation for people to keep building, and because it's necessary. Yeah, so look, it's hard to give any specific advice, but any help would go a long way.
Thanks for that. Yeah, happy that we can at least do something with this event. Fascinating stuff. Let's give a chance to our audience. Let's see if we have any questions. It's the very last moment to type in your questions, guys. Let me see. Do we have anyone waiting for the answers? All right. Looks like we are all set. Means that your explanations were very precise. Is there anything else we should mention? I mean, what is your plan for the future? I mean, from this technological perspective.
Yeah, look, I think we're just touching the surface, sort of globally, with this opportunity. We really want to get entrenched in these farms and become more of a standard way of operating. Technology, like I said, I think our view is more to go up the supply chain and use this data throughout, focusing where we're focusing. I think, yeah, and just sort of growing our footprint globally.
Right. We have a first question. Obviously, there is a slight delay. Yes, exactly. So, a question: Can you get back to your motivations and dive into it a little bit more? Obviously, with your background, you have plenty of choices.
Yeah.
Why agriculture, and why startup at all? Why not joining existing company?
Yeah, look, I've always been entrepreneurial. I've also always thought that South Africa has been a really good place to build a business, to be honest, because of the access to talent and the relative low cost of that talent. Um, Agriculture, so as I mentioned at the beginning, my partner James came from agriculture background, and just on analyzing different opportunities, we saw huge opportunity. Like it almost was a non-negotiable that this technology be built in this space. We could see that this was where opportunity was. Also, just from an impact perspective, like outside of the financial opportunity, it's personally, I'd always said I'll either work in the agriculture, the health, or the education space. Just because I think that's where sort of the most impact can be made, at least locally in South Africa, and this just ticked all those boxes.
Right, right, makes a lot of sense. We have also the kind of like a follow-up questions. What are your suggestions for a professional interested in precision agriculture startup?
Oh, it's difficult to give sort of broad. I mean, maybe another point. I'm not necessarily the right person to give advice. I can share experiences. I've only done this once. I think. I mean, firstly, go for it. Like I said, there's so much opportunity in this space. I think the biggest challenge is getting customers early and sort of doing all you can to get big key relationships early on and using them to sort of do your marketing for you. Like relationships in the space and trust are everything. And if you've got a network in that space yourself, it's great. If not, I would try find a co-founder or something in the sector. I mean, I'm assuming this is meaning to sort of start your own startup versus joining an existing one. There's just so much opportunity out there, to be honest. I think within the monitoring space, within the application space, I think just like agriculture is so broad and so wide. I'd suggest just focusing as nichely as possible to begin with. Like invariably, that niche would be a big enough market anyway for you to build a sort of global business off of.
Right. Thanks a lot, Benji. Thanks a lot for that. We are running out of time, so it is my honor to thank you all for joining us today. It's been a pleasure to host this discussion. I have a feeling that we could spend another hour or two diving into all of these aspects. Hope we leave our audience with some valuable insights into the future. Benji, huge thank you for joining, for sharing all of these insights.
Thank you.
Hope you will maybe join us again sometime.
No, thank you for having me. I enjoyed the conversation.
Thank you. Thank you all for coming. See you at our future events. Have a great